That was a great lead into why build a platform from innovation and why the research and education community is the right place to do that. So I'm going to take from there and talk about the platform that we're building. So we've partnered with Internet2 and with Stanford University to build this platform. Some of the lead developers from the team from IU that are developing the software for this are here today. We have a demo outside if you haven't stopped by to see it. And so I'll talk a little bit about what we're doing, why we're doing it. But I wanted to start off with sort of my key takeaways from yesterday. I thought that the talks yesterday were wonderful, and I wanted to start with some notes because I think it's relevant to this. So, unless you were sleeping yesterday, I think you heard many times that networks are very, very complex, and that the pace of innovation is not keeping pace with the innovation that we're seeing in software and devices and servers and storage and other areas. Talked about how SDN is all about creating these layers of abstraction, defining the interfaces between them as a way to increase the pace of innovation. SDN is not just another protocol. It's not that thing that's going to fade away. This is not a protocol per se. It's a whole new architecture, a new paradigm for how we build networks and how we'll build networks into the future. And we're only starting to develop this. Some of us, particularly within the academic community, have been working on this for 2, 3, 4 years, but really, we're really at the tip of the iceberg here, and there's a whole lot more work to be done. Just to go over a little bit about what Rob hit on, innovation in universities. He talked about some core networking innovations, TCP/IP, routing, other things like that, as well as application innovation, putting 100 meg into all the dorm rooms and the things that could create as a platform. No one knew what those students were going to do when we put 100 meg in there. Why would you need 100 meg in your dorm room when most people have 28.8 at home? But universities invested, they put it in there, and a lot of things happened because of that. Sometimes you have to challenge the status quo. When I first came to IU in 1999, I still heard these great, passionate stories about these crazy, free-spirited academic computing guys who thought this TCP/IP thing was the great thing, and the administrative computing guys who thought they were completely nuts. The SNA was the way of the future. So sometimes you have to challenge the status quo. And you need to invest in platforms that support innovation. So that's what we're talking about doing. And R&E networks are a great way to do that. And one reason is today's R&E networks bear a lot of resemblance to the commercial networks out there. If you looked at the diagrams of the Internet2 network, it's based on dark fiber IRUs, dense wave division multiplexing. There's Ethernet, there's IP, there's MPLS. The configuration of our network looks a lot like the configuration of a lot of the other networks out there. But we have a mission to innovate. When I first came to IU from the commercial sector, I couldn't quite figure out what motivated people. What motivates you? There's no revenue here that you're getting. What motivates you? Well, what motivates you is to do the next cool thing, to invent the next cool thing before the guy next door does it, right? And that's what we're all about, and that's why we build that thing. So that's what makes us different. We're scaled for cutting-edge technologies. The Internet2 backbone does not have 3,000 routers on it. It does not have hundreds of thousands of customers. It looks a lot like the other networks, but we're scaled where we can take things that are very cutting edge, we can get them out there, and we can do it quickly. And we have a large community, researchers, students, and for all of you, these are the next generation of developers, of engineers, of folks that are going to staff your company. So here's a little bit about NDDI. So it stands for the Network Development and Deployment Initiative. Again, the founding partners. And the mission here is to create an open, global scale platform based on SDN to enable the next generation of innovation. If you're interested in more, there's a link there. There's actually some really good documents there that go in really gory detail about why we're doing this and exactly what we're doing. So the origin here, so one of the origins is, so Internet2 is run by its membership. The members tell Internet2, here's what you should be doing. And they said, you need to go build this national Ethernet exchange. And we want it to be 100% self-service, meaning we want our users to be able to go in, they want an Ethernet connection across the country, whatever 2 ports they want, completely self-service. They go in, they set it up, traffic flows over it, monitoring set up, both through a web API and through a programmatic API, and said, oh yeah, and by the way, if you can support OpenFlow, that would be kind of a cool thing too. But then we look at SDN and we said, if you're going to build this kind of network, the way you build this is on an SDN architecture. You want to build a programmable network that people can go in and configure. You want it to be flexible. This is the way we want to do it. And there's this other thing going on, been going on for a couple of years, called GENI, which has been talked about a couple of times. I think we have, there's some folks from the GENI project here today. GENI stands for the Global Environment for Network Innovation. This is a National Science Foundation funded project, and the goal of GENI is to build a unique virtual laboratory for at-scale network experimentation. Want to build that on a shared, heterogeneous, highly instrumented infrastructure. So if you want to do experiments, great, you can go out and run them, but you also need instrumentation there to figure out whether they did or they did not work. The other goal is to enable deep programmability throughout the whole network, and for you who have been here for a couple days, I think that's a theme we've heard over and over. So here's a little bit about the architecture. This is really high-level architecture, how we're going to go about building this, right? So this kind of looks pretty familiar, I would think, from what you've seen over the last couple days. So it's OpenFlow, it's SDN, build the virtualization layer, and then be able to plug in multiple experiments, multiple services in slices on top of that. So the idea is that you can deploy this across the whole network. Different experimenters can come in and deploy new things on top of the infrastructure. So the first thing we built is what I described. Don't ask me questions about the technical details. We have folks who build all this. But it's a service called the OS3E, the Open Sciences Scholarship and Services Exchange. And this is what I talked about in terms of building this nationwide Ethernet fabric with 100% self-provisioning. And so this is sort of the software architecture that, again, we have it demoed here. It's actually live. We have 4 switches in the field today with a 5th coming, and starting to connect beta customers with a goal of going production by the beginning of next year. All based on open source software. So OpenFlow switches, the Knox controller, open source controller, an abstraction layer that we have built on top of the controller, and then an open source application on top of that. Shortly, I think after the first of the year, all of this will become open source, and the goal is to get other universities, other networks, to take this and to deploy it, to put it out there, to get people using it as a platform for innovation. If you look at what we've done here, put a lot of time, a lot of thought into building the same things that you would think about building your networks in terms of scalability, redundancy, security, all of that, baked into here. So when I think about what kind of innovation are we going to support, how we're going to do that, I really break it down into 2 pieces. And one is sort of the evolutionary innovation, which is to take the existing control plane functionality and build that on top of this new open architecture in which lots of people can get in and build on, right? This is what the National Ethernet Exchange Service is one piece of, right? So you could go build something like that on a traditional architecture, but let's go build it on this new open architecture so then we can innovate it going forward. We're not going to stop by just replicating building VLANs across the country. We're going to build on top of that and move that forward. The other piece is the revolutionary part of this, which is what the GENI project is doing and what we're going to move with the architecture you saw onto the NDDI infrastructure, which is let's create a test bed using the same technology that we're going to go build our production services on. Let's build a test bed with us, let's slice it, let's virtualize it, and let people go out and try things. Again, like Rob said, we don't know what they're going to do. Let's build a test bed, let people try things. So here's the obligatory diagram that shows what we're building. There's roughly 35 nodes on there. The yellow lines show what we have built out today. This is a 10 gigabit backbone. We have the capability in the hardware we already have today to do 40 gigabit. And over the next year or so, we're going to build out the rest of the network. So you want to jump in?
So the last piece is a call for participation. So this is, I said when I started my talk that, the we, the Internet 2 was formed by is a community. And it's a community that involves academia and it involves corporate partners. Anyone in this room is welcome to use this platform. We think with NSF's extensions that they're working on the campuses, that within a year or 2, you're going to see a very rich, multi-domain SDN environment that potentially gets you end users, labs, all kinds of devices, et cetera. And we want this to be the platform where people think about trying these large experiments. We've got partners in Europe, in Asia, and South America. who are already signing up to connect with this. So we think this is a place where large-scale innovation can happen, and we welcome participation from anyone that wants to be part of it.